Hello, welcome to Prajim Technologies. I am Venkat. This is part 38 of SQL Server. In this session, we'll learn about what are the advantages and disadvantages of indexes, the types of queries that can actually benefit from indexes, and we'll also cover a concept called covering queries. Now, before continuing with the session, I strongly recommend to watch parts 35, 36, and 37 of this video series. So what are the advantages of indexes? Now in part 35 we have learned that indexes are used by queries to find data quickly. Okay, so if you look at the table that we have here, it's employees table, which has got ID, first name, last name, salary, gender, and city columns. And on this table, the ID column is the primary key column, and we know that when we have a primary key constraint on a table, by default it creates a unique clustered index on that column. So since this is a clustered index, the ID on the ID column we have a clustered index, the data is arranged in the ascending order of the ID column. But if you look at the salary column, this is not arranged in any order because the data is already arranged in the ascending order of the ID column. Now on the right hand side you can see an index on the salary column. Okay, and if you look at the salaries, they are arranged in ascending order. Okay, and then for example, if I want to find out who is the employee who has got 2500 salary, you look at this row and there is a row address. We pick up that row address and get the row which has got 2500, which is John's record, directly. Okay, so this is a non-clustered index and this is the table. Now let's say somebody writes a query like this: select star from TBL employee where salary is greater than 4000 and salary is less than 8000. Now if you look at this, I want all the employees whose salary falls between 4 and 8000. So obviously this query can benefit from this from this index on the salary column, because salaries are in ascending order, so the database engine can quickly narrow down the rows that fit into this category. So if it starts at 3500, no, it doesn't fall into this category, but 4000 falls into this category, so it starts from there and takes everything until 8000. And then it has the row addresses, so it goes to the actual table and retrieve all the other columns that we are requesting in the select clause. So select statements with a where clause can benefit from the right indexes. Even delete and update statements can benefit. Now if I want to delete a particular record, let's say for example I want to delete an employee whose salary is 2500. Now assuming that I have a million records in this table, now obviously if I have to find all the employees whose salary is 2500, I'll have to look at every record. Instead of that, if there is an index on the salary column, 2500 people with or rows with 2500 will be present, consecutive will be present in consecutive rows, so they will be adjacent to each other, and it is easy to pick those row addresses and then go to the base table and delete these rows. And along the same lines, update queries can also benefit. Okay, because we are updating the salaries of all people whose salary is currently 7500. We are updating that to 900, so all people with 7500 will appear in the index next to each other. So get all those rows and update in the base table. Okay, not only select, update, and delete, order by queries. Okay, look at this. I want all the employees ordered by their salaries in ascending order. Okay, if we don't specify ascending keyword, by default the salaries are arranged in ascending order. So now if you look at the index itself, the salaries are already pre-sorted. So the database engine can simply scan this index from the beginning till the end, take the row addresses, go to the table, retrieve them in the same order. So this avoids sorting the results during query execution. It simply has to scan the index, retrieve the row addresses, go to the base table, retrieve them, and there's no additional step of sorting those results during query execution, which will significantly improve the performance of the query. Not only sorting the salaries in ascending order, even if you want to sort the salaries in descending order, the database engine has to simply scan the index in reverse order and then retrieve the results from the table. So both order by ascending, order by descending queries can also benefit from the right indexes. And along the same lines, even group by clause can benefit from the index. Okay, now what we are trying to do here, we are grouping or we are counting the total number of employees at each salary. For example, I want to find all the salary, the total number of employees who have got 2500 as salary, 3500 as their salary, and then I want the total number of employees in the next column. So obviously, to achieve that, we have spoken about group by clause as well in our previous video sessions of this video series. Okay, so basically we are grouping employees by salary. Okay, so we know that in the index, employees with similar salaries appear next to each other. Okay, they will appear consecutively in this index, so counting them will be relatively easy. From the beginning till the end, scan the index, find the rows which have similar salaries and count them, and simply return that result. So group by can also benefit from the index on the salary column. Alright, let's look at the disadvantages of indexes. Now, we spoke about the advantages. Basically, indexes help queries to find data quickly. So what are the downsides? The downsides, obviously, additional disk space. Now, if it's a clustered index, here on the ID column we have the clustered index, so we don't require an additional disk storage space. But if it is a non-clustered index, the index is stored separately. Now, let's say I have 10 columns in a table, and let's say I create 10 indexes, non-clustered indexes, for example. Okay, now as these non-clustered indexes are stored separately from the base table itself, they require additional disk storage. But these days, disk storage is less costly. We can actually trade that for best application performance. So clustered indexes doesn't require any additional storage. Every non-clustered index requires additional space as it is stored separately from the table. The amount of space required will depend on the size of the table and the number and type of columns that we are using in the index. Okay, obviously if we create a composite index, then there are more number of columns in the index, and the amount of space required will be more. What is the other disadvantage? Insert, update, and delete statements can also become slow. Now, in the previous session, in the previous slide, we said that, if we have delete and update records, obviously they can benefit from an index. But here we are saying insert, update, and delete can become slow. That's because, see, in order to delete or update a record, we need to locate that. That time to locate can be reduced. But then, if the tables are huge and if there are too many indexes, when you delete or update records, then the indexes needs to be updated as well, all the indexes. Now, if you look at this, for example, if you look at this employee table in this index, let's say, for example, I am deleting an employee with salary is equal to 5,000 from the table, 2,500 from the table. So John's record will be deleted. 2,500 salary, John record will be deleted from the table. Now, when that record is deleted from the table, it also has to be deleted from the index. Okay, so if there are 10 other indexes which are referring, his first name, his gender, city, obviously all those indexes needs to be updated as well. Okay, so that's why if there are too many indexes, they can actually affect insert, update, and delete statements. Okay, so DML statements, data manipulation statements, insert, update, and delete modifies data in a table. The data in all the indexes also needs to be updated. Indexes can help to search and locate the rows that we want to delete, but too many indexes to update can actually hurt the performance of data modifications. That's why index tuning is a very important task. You have to choose the right number and type of indexes. Alright, so those are the two disadvantages of indexes. So what's a covering query? Covering query, if all the columns that you have requested in the select clause. Now let's say here, if you look at the index that we have the index on the salary column. Now when I say select star from TBL employee where salary greater than 4,000 and less than 8,000, I'm saying star, meaning I want all the columns first name, last name, salary, gender, city. Now obviously these columns, first name, last name, gender, are not present in the index. So from the index we have to look back in the main table and then retrieve those columns. So there is a lookup involved. But then if I just say select salary from TBL employee, where salary is greater than 4,000 and less than 8,000, then salary column that you have requested in the select list is present in the index itself. So here the query is being covered by this index. So that's called a covering query. Now we have spoken about composite indexes in part 35 or 36. Now, when we create composite index, a composite index is basically an index on two or more columns. Now, if I create a composite index, let's say on first name and last name, obviously if the chances of that index covering a query are more. So basically covering query, if all the columns that you have requested in the select clause of a query are present in the index, then there is no need to look up in the table again. The requested columns data can simply be returned from the index. Okay, a clustered index, here the ID is the clustered index. If this is chosen, when we execute a query, then a clustered index will always cover a query because all the columns are present in the table itself. So when I say select star from TBL employee where ID is equal to 5, so you are saying star, which means you want all the columns, ID is equal to 5, so obviously it uses the clustered index there and then it retrieves everything from the same table. There's no lookup involved. Okay, so a clustered index will always cover a query, and the chances of composite index covering a query are a little more. So covering query is nothing but if the requested columns are present in the index itself, there's no need to look up the base table. So in that case, that index is covering the requested columns in the query. So that kind of a query is called as a covering query. On this slide, you can find resources for ASP.NET, C# and SQL Server interview questions. That's it for today. Thank you for listening. Have a great day.